All right, can everybody hear me and can you see my the presentation? Because I just want to make sure everyone can hear and see me before I start so I don't have issues throughout it. All right, we're good. All right. So we'll just wait here about 20 more seconds to 2:20. All right, so we'll get started. So my name is Joseph Pennock. I am the team captain of FTC team 18457, the Gator Bites from Newbury Park, California. And so this presentation breakout session is going to be about how to design competitive drivetrains for use in FTC. This is going to be an overview. This was written before the game was released. It was written about a week ago, and some things are slightly going to be changing because of just the differences that we do see this season as far as movement and rules. So let's get started. So what are some of the general requirements that we see for a competitive FTC drivetrain? So it can vary from team to team. Some teams value other things more than others, and it can become a giant mess. So I've compiled a short list of the 4 things that my team and I myself personally have found over the last few years to be kind of important to what our team tries to do, and that is speed, weight, size, and agility. And so speed, we'll start off. It's arguably one of the most important attributes for a drivetrain. Is it speed? The faster drivetrain is, it can cycle faster, which means you score more points. You can avoid defense that's being played against you. So that's also another huge upside. Weight kind of goes hand in hand with speed because the lighter drivetrain you have, you can have a higher gear or a lower gear ratio, which allows for your robot to go faster, which is always an upside. So those two kind of work together. Size, you generally want your robot and drivetrain to push its footprint perimeter to a 17.5 by 17.5 inch cube. That's half an inch under the 18-inch square. It just allows for tolerances in inspection, so you don't fail inspection. And with that size, you have a lot of space to build game-specific mechanisms on top of the robot. And agility. Having an agile drivetrain is important. It's at the bottom of the list because you can be without it, but it is nice in some circumstances, such as navigating around objects, obstacles, or any defense that's being played against you. So once again, speed and agility also kind of go hand in hand. So we'll move on. What are the different types of drivetrains? So when we talk about drivetrains generally, as far as the types go, there's 2 main different types. That would be tank drive and holonomic drive. Both are commonly used in FTC, and both require integration with software, hardware, and the rest of your robot to be used to their fullest potential. There are 10 different subgroups of each of these. So 5 for tank drive, 5 for holonomic drive. And so we're going to be going over those here in just a second. But yeah, so the 2 main are tank drive and holonomic drive that are used. So tank drives. A tank drive is driven with 1 or 2 motors on each side of the robot, driving 1, 2, 3, or 4 wheels per side. There are 5 common types of tank drives that make up what I would say is 99.9% of the tank drives that we see in FTC, and that would be the 2-wheel drive, aka pushbot, the 4-wheel drive, 6-wheel drive, 8-wheel drive, and tread drive. The one thing about this tread drive, it's one of the only pictures I can find. It's not very common. They did use 3 motors on each side to power their treads just for that extra torque. So that is something that is slightly off from the 1 or 2 motors on each side idea. So when we move on to the 2-wheel drive, it's also known as a pushbot. It's the most basic form of a drivetrain that we have in FTC. And normally it has 2 traction wheels and 2 omni wheels, with the traction wheels being driven and the omni wheels being undriven. And these are either at the front or back. And so there are design limitations, and it's not great. It is used, you can use it. My team was semi-successful with it first year. On my first team, which was like 2 years ago, we were semi-successful using a tank drive or a push bot tank drive. It's low traction. You don't have that much grip with only 2 wheels powered. You have limited options as far as design goes. You have an off-center pivot point, which means that when your robot rotates, the front or back is going to swing more than the other opposite end is, just because of the design. It is a simple design, so that does help for like newer builders and teams building a robot that they can compete with. There's not going to run into as many issues as far as engineering wise with the 2-wheel push bot drive than it would with other drivetrains. It's most of the time kit built. Tetrix, Rev, GoBuilda, Actibotics. You can use to build a basic push bot and it will work. And it's 2 motors. So hypothetically, if you need 6 motors, you can use a push bot and you can use the other 6 of 8 to do whatever you need to do as far as attachments or assembly wise on your robot. Moving on to a 4-wheel drive. The 4-wheel drive is a modified push bot, and it has all 4 wheels powered. So you still have the 2 traction and 2 omni wheels, but they're all 4 driven, normally by 2 motors. So each wheel is independently driven. So it has its own power source and torque. This can be very useful for traversing terrain on the field, as well as playing defense. If you use a tank drive with 4 wheels, the 4-wheel drive is easily the best option for you. I rank it at a C tier, on like a tier list. It's in the middle. It has good acceleration. It can play defense competently, I'll say. It does need some weight balance as far as like turning and stuff to be perfectly accurate. It's a fairly simple design. Most of the time it needs to be custom built. I have seen some kit built ones, but you start running into issues. And it does, to be effective, it needs 4 motors. If you don't use 4 motors, it's a push bot. It's as bad, if not worse, than a push bot, because the torque is not just being given to 1 wheel from the motor. It's having to be split up over 2 wheels, which is really, really bad for acceleration. So that's the 4-wheel drive. 6-wheel drive. 6-wheel drive is very interesting because I think it will be used a lot this year. I'll talk about that in a minute. But it's probably the most popular form of tank drive that we see in FTC. It utilizes 4 motors, 2 on either side, that drive a center wheel and that are then connected to a traction or omni wheel at each corner through either belts, chains, or gears. 6-wheel drive can be the fastest drivetrain and the most effective and be very effective at defense with a proper implementation. I give it a rank of S tier just because of how good it has been in the past and how good it has the potential to be with proper implementation. It has great acceleration, great defense. It has a center pivot point, which is perfect. You do kind of need a design plan going into it because if you're doing belt or chain or gearing, it's going to be a lot of figuring stuff out. You don't have to buy stuff 20 times to make it work. It can be custom or kit built, and it does need 4 motors. Please do not use 1 motor on a 6-wheel drive. You're then just splitting the torque of that motor over instead of 2 wheels on the 4-wheel drive. You're splitting the torque from that 1 motor over 3 wheels on either side, which is not a good idea at all. A lot of issues can arise from doing stuff like that. So we'll move on to the 8-wheel drive. It's probably the most powerful form of tank drive that has been made so far. It's very similar to the 6-wheel drive as far as design, but it needs a center drop of the 2 center wheels more often than not. And a good 8-wheel drive design should be able to play defense against any FTC robot that it faces in a match. Except maybe tank drive or the tread drive, you could run into some issues playing defense against them, but it would be a very, very even match. A good 8-wheel drive also should have, once again, 2 motors, because you don't want to divide 1 motor up among 4 wheels on either side. It has good acceleration. It has the best defense. It can turn slowly and be kind of sluggish when turning. So that's my issue with this 8-wheel drive, is just the sluggishness of turning. It does need some sort of design plan when you go into it, as far as design wise and how you're going to do power transfer from motors to the wheels. 99% of the time, I'd say it's custom. I don't really see that many 8-wheel drives that are kit built. It's probably possible, but I wouldn't recommend it. I'd recommend just custom building it. And it does need 4 motors. Don't use 2 motors on an 8-wheel drive. That's a recipe for disaster, in my opinion. So that's 8-wheel drive, very similar to 6-wheel drive. I recommend 6-wheel drive over 8-wheel drive. Moving on to the tread drive. This is where it gets kind of interesting, because this season, with the terrain that you have to cross to pick up the cargo in the warehouse, I think tread drive will be used by more teams than it has ever been. It's an interesting concept in theory, but in practice, it falls flat. I don't want to say flat on its face, because it has been implemented semi-successfully. But a tread drive requires a ton of research and development to be effective. And even with all that research and development, is prone to failure, because if you have your treads hit, they could be knocked off track, broken, or a ton of stuff can happen. There's a ton of points of failure, which we try to limit in mechanical design. And I personally would avoid it. Some teams are going to use it. Some teams are going to probably be successful with it. But it all depends on what sort of development they can put into their drivetrain and how effectively they can mitigate risks from it breaking. Tread drive does have a low top speed. It has the best traction. It's fragile against defense. You have to have a design plan. It's going to be custom. You're probably not going to be able to build a kit tank drive that easily. And it needs 4 motors. So moving on to holonomic drives. And a holonomic drive is different from tank drive, as it is able to not only move forward and backwards, but it's also able to move side to side. There are 5 common types of drives that are used that make up 99% of the holonomic drives that we see. That would be the mechanism, X drive, H drive, swerve drive, and differential swerve drive. So if we move on to the first one, that's going to be mechanism drive. I'd personally say that mechanism drive is probably the most popular in FTC. Most teams use it, and most teams are very, very successful with it. The way mechanism drivetrains work is you have special wheels that each have angled rollers, and these rollers, when you spin the wheel, turn, and they create a force vector, and those vectors are then with the 4 wheels are all put together and are able to translate and make the robot move in the direction you want. Another big upside to mechanism drivetrain is you can build a very, very, very solid drivetrain using kit parts, such as gluten-free, and their robots that they have won world championships with. They used Actobotics. My team does use the mechanism drive. We personally think it's the best. We're going to look at possibly switching this year, depending on how stuff goes. It's an S tier for me because of its effectiveness. It has good acceleration. It can play defense. I wouldn't recommend it. With proper design, it can play defense competently. I'll say it's not going to be a 6-wheel drive or an 8-wheel drive playing defense. It does have that center pivot point, which again is really, really good. Strafing is slightly slower than driving forward, because you do run the risk of, or not run the risk, but you just have the difference as the vectors are slightly more powerful in the forward direction than they are in the side-to-side direction. It can be custom or kit built, and you have to have 4 motors to run mechanism drive. You cannot run it with 2. You have to have 4, otherwise the wheels and the force vectors, the way they're supposed to work, won't work properly. Moving on to the X drive. The X drive used to be quite a bit more common in FTC. than it is now. But over the years, just usage of it has just dropped off because what we've seen with Mecanum wheels becoming so good. If you need an X drive, probably would work. An X drive would probably work to an extent, but the lack of traction, because you have Omni wheels in four corners, is a huge problem if you are playing against any sort of defensive robot that's not an X drive, because they are going to be able to push you around really easily. So basically, the basic rule is for X drive, if you have the money, go Mecanum. It's a C tier because it's been very effective in the past, but I wouldn't recommend it. It has poor acceleration. It cannot play defense at all, really. It has a center pivot point, so that's nice. But its strafing is not great, and it can be custom or kit built, and it requires 4 motors. I've seen some concepts of a 2-wheel or a 2-motor X drive, but that just scares me as far as building that and getting that to work. And torque wise, you're already limited on traction and you have poor acceleration, and you're just making it even worse. So I don't recommend doing a 2-motor X drive at all. Moving on to the H drive. So the H drive is one of the special holonomic drivetrains because it has the capabilities of strafing, which makes it holonomic, but it has the properties of a tank drive, specifically either 4 or 6-wheel drive. The H drive uses a tank drive layout with its wheels plus an added center omni wheel or grip wheel that allows it to strafe side to side. You do need a bunch of planning, and sometimes you need custom suspension for that center wheel to work properly. But it can work it can work, I won't say really well, but it can work well if you implement it correctly. You have good acceleration, great defense because you have those properties of the tank drive. It is a very complex design. Strafing isn't great. It can be custom or kit built, and it's got 3 or 5 motors. For me, it's a B tier. It's not perfect. There's a lot to be asked of it that you could add that'd be much better. And it's somewhere in the middle. It's not terrible, but it's not super, super good. So moving on to a swerve drive. So swerve drive is commonly found in FRC. We don't see them that much in FTC because of our limits on motor usage. We can only have 8 motors plus 12 servos. And a swerve drive would either take all 8 motors or 4 motors and 4 servos. And I have seen swerve drive designs that have been made using servos, but innovation is going to be needed as far as those designs go to make swerve drives one of the best drivetrains you could use, as the time that it takes to turn the actual wheels so you can move side to side needs to be cut down. And right now we don't have any servos that have enough torque and can move fast enough to do that. So that's kind of that. It has great acceleration, plays great defense, basically 4-wheel drive defense. There is strafe lag, which is what I was talking about, where you have to turn the wheels. It has the fastest strafing out of any holonomic drivetrain. It's going to be full custom. You can't really kit build a swerve drive. It's very hard to do. Theoretically it's possible, but it would be very, very complex and probably wouldn't be anywhere near as good as a custom one would be. And it does require 4 motors. So the differential swerve drive is interesting because it is probably the best holonomic drivetrain besides the Mecanum drive. Objectively speaking, the motors are connected to 2 drive gears, basically, that spin opposite of each other. And then there's a wheel in the center, which you can see in these pictures is the gray wheel. That is on a differential. And so as those bevel gears that are connected to the drive motors spin, it can spin the wheel. And while that wheel is spinning, you can also turn the wheel based off by varying the speed of the top or bottom gear. With a proper implementation, a differential swerve drive is good. It's not going to be as good as a Mecanum as far as just ease of use, but it's good. I give it an A tier because of some of the promise I've seen with it. has great acceleration. It can play good defense. It doesn't need servos compared to the regular swerve drive. It has fast strafing. It does have to be custom. If anything, this differential swerve it does require custom parts. It'd be very, very, very hard to do without machining or 3D printing something. And it does need 4 motors because it needs to power each wheel. So trying to decide which drive platform to use, it's a complicated process because you need to take into consideration what your team strengths are, what your strategy is, and how the game is built for the season. So because the drivetrain is the foundation of your robot, if it's subpar, you could limit your scoring capabilities and kind of limit yourself when competing. So here are a few of the things. I'm just going to make a list of things that can influence what drivetrain you use. So if you want to play defense, use a 6-wheel drive, an 8-wheel drive, or a swerve drive. And it's hard to put a swerve drive in there because of just some of the issues with it as far as torque for the servos. Does the game require precise movement? If it requires precise movement, I'd use a mechanism drive, such as in Skystone, where you had to place the blocks on top of each other very precisely. Mechanism was easily the best for that. If you can make custom parts, I'd look into doing one of the swerve drives as an off-season project. And if you get good with those good results, possibly use it in a season. If you need to be as fast as possible, use a 6-wheel drive. It's simple as that. Use a 6-wheel drive if you need to be fast. If your team is limited to 4 motors overall in your entire robot, say you're just using like a base kit and 1 expansion hub or control hub, you can't use the expansion hub and control hub or 2 expansion hubs. You can only use 1. Look into an H drive or the pushbot. They're both options that can work. But if you have the money, just get an extra expansion hub so you can have 8 motors and you can be faster and use much more competitive drivetrains. If you need an easy drivetrain to build, look into the mechanism or 6-wheel drive. As far as complexity goes, those are like your best bang for the buck value as far as design time that you put into it. If the game has terrain, I would personally look into a 4-wheel drive or a 6-wheel drive can work, but mostly 4-wheel drive or swerve drive. So that's quite interesting this year because we do see the return of terrain on the field. And if you have the development time and money for a complex drivetrain, if so, I'd look at a custom mechanism or 6-wheel drive or differential swerve, just because there's so many upsides to those drivetrains they're so good. I would definitely look into using those. So when you're choosing between a custom or kit drivetrain, they're like the 2 main options. A custom drivetrain is going to have 2 plates and wheels and belts and or gears or chain powered by the motors. A kit drivetrain is going to be made using channel or extrusion. Both are very competitive, and both the pictures on these slides. So the one on the left, that's a design for our team's robot for this year. This is, I think, version 2. We're on version 3 right now. And the one on the right is our drivetrain from last year. That was version, I think, 14.2. And so we got up to 14.6, I think. We just switched out a few bits on that. So they both worked very well for us last year. When we go and look at designing a kit drivetrain, you need to test and prototype different designs. And from those tests, you would choose what's the best design to build a drivetrain. But a year or 2 ago, GoBuilder released their Strafer chassis, and then they released their 6-wheel Beeline drive last year. And so both of these drivetrains, they're extremely competitive and complete, and they show a solid design that if needed, you can buy it as a complete kit and use that with the peace of mind, knowing that it's probably there's not going to be any major issues. The kit drivetrain can still be built with other parts, but it could have issues the GoBuilder kits have already ironed out that you could run into. How to design a custom mechanism drivetrain. So this is the point of the video where I'm kind of going to switch from what are the types and more of like choosing a type of drivetrain to more of designing a custom drivetrain. So I'm going to be doing how to design a custom mechanism drive because I have the most CAD resources and other materials for that. But when designing a custom drivetrain, there's a process that you have to follow. And I've kind of just made here a list of the process. First, you got to design a sketch of the side view, the drive pod with all standoffs, axles, mounting points, motors, and belt lengths. Then you have to create a final sketch of the inner and outer plates, pocketing if your material allows for it. So you can't pocket carbon fiber, that'll lose its strength. You then need to create wheel and motor assemblies so that they fit into the specified mounting points. Assemble all of your parts into one design for each of the two drive pods. And then you need to measure the width of each pod and figure out how long of a cross beam you can have. And then choose which cross beam you want. And then assemble your drivetrain and see what it looks like when you're completed if you're happy with it. So to design a layout sketch, you have to lay out where your wheels and axles are going to go. If you're going to have a top plate, you need a spot to put top plate mounts. You need to have a spot for your motors and motor mounts to go. Support standoffs, such as like just wherever there's like some weakness, you can put support there. And then your odometry pods and mounts for mounting odometry to the drivetrain. So that's kind of the first step. The next step is to create a final sketch of the plates. To do that, take the primary sketch and like graph out where draw and sketch out where the holes for everywhere, all the holes you want it to be in the final product. And then what you need to do is, if you want to, you can either put in mounting points like I did here in this, and or pocket the plate. So I kind of did a combination of both. I put a bunch of mounting points, and then I pocketed each end where kind of the wheel goes, just to save on some weight. And you can only pocket really if you're using aluminums or steel, as it will save lots of weight. It's not as much worth it if you're going to do like Durlin or polycarbonate, though it can still be useful. And just reminder, you can't pocket carbon fiber because it will lose its strength because of those interwoven fibers. Continuous fibers, you get that taken away and you lose strength. So to design wheel assemblies, you have to choose whether you're using a dead axle or live axle setup. So for this example, I'm going to be using a dead axle setup because it's what I have CAD for, and I personally think it's the best. To make a dead axle wheel assembly, what you have to do first is connect the wheel and pulley that you're going to be using with a 3D printed custom spacer made with PLA, ABS, PETG, or similar material. I use PLA. I might reprint with PETG just to make it a little bit stronger. And then you're going to want to measure the distance from one side of the pulley to the other side of the wheel. And this allows you to, when you take the measurement, you can choose an axle that fits. And to choose an axle, I chose 56 millimeters because it would work. And then you can put bearings on either side of the wheel and pulley and just have that sit right on the axle. When we move on to designing the motor mount, we need a strong design as the torque from the motor could cause slippage in the system, especially if you're using belts. You need to pay attention to the spacing that you have in your primary sketch with your wheel and motors, because that center to center distance that you had with your chain, belt, or gears is very important. You need to keep that. And so what I do is I take the motors and I face mount them to a custom plate that I cut normally out of like 6061 aluminum or even steel. And then I attach standoffs to that plate, and that allows it to just be like inside the pod a little bit. It saves space in the center of the robot, so you can say you have like odometry in the middle, and then you have the belts on the very outside of the drive pod. To then start assembling the drive pods, you need it's first assembly. It's kind of a test to make sure everything fits together. If you find that you have a part that doesn't quite fit, go back to through the CAD and change the parts that you need to change so everything works properly. If you've made it, the drivetrain pod and everything fits together, you can go through and start final assembly of the drivetrain. So that's just kind of it's just a final test before you manufacture anything. What you need next is you need to choose a crossbeam. So choose a crossbeam. You need to basically have a crossbeam that pushes the very edge of each of your drive pods far enough apart so you're at about 17.5 inches. And 17.5 inches is like a good ballpark number that you want to aim for because of tolerances with the sizing tool that they'll use in inspection. It's just nice to have that little bit of extra leeway in case there's some sort of issue. You'll be good. And by using rev extrusion or other extrusions such as Mizumi, you can cut cross beams to the correct length that you need them to be. And this takes out any sort of air and you can push it right up to 17.5 inches. But if you're using channel for a channel-based cross beam, you need to find a piece that fits, which can be harder to do. But what I have found is GoBuilda has the best selection of channel lengths. They have, I think, them in increments of 24 millimeters. So that can be really, really useful just because you have a lot more options as far as like design goes. And it's just a lot easier to use when you have the peace of mind that it's going to work and it can be a lot stronger. So to assemble the full drivetrain, you just connect the two drive pods with the cross beams. So that's just kind of like assembly is fairly simple for the last step. So this has kind of been a process for what I use to make custom drivetrains for my team. It's not going to work exactly for everyone, the process I've described here, but it is a generalized outline for like kind of something to follow. And I hope you can modify like kind of what I do to fit the way your team does stuff or the way it works best for you. So just a little presentation summary. Drivetrains I do recommend: 6-wheel drive and mechanism. Those are the two I recommend the most. Other things can work, but in the end, 6-wheel drive and mechanism are the best for FTC from what I've found and from what others have found. The process for making a custom drivetrain is design a sketch of the side view of the drive pod, create the final sketch of the inner and outer plates, create the wheel and motor assemblies, assemble all the parts into one design for each of 2 drive pods, figure out how long of a crossbeam you use, and assemble the final drivetrain. So that's basic summary of the entire presentation. So my contact info, if you have any issues or questions about designing your own drivetrain, feel free to reach out to me. Here's my Discord and my email. Just send me a message. I'll try to get back to you as soon as possible. I do have school, so I won't be able to answer right as you send it, but I'll try to get back to you within 24 hours with anything that you really need drivetrain wise or design wise. So I hope you've enjoyed this breakout session and that you've learned something that you can apply to your robots to make them even better this season. And I'm looking forward to seeing everyone and their robots at competitions this year. And yeah. So now that we're done with this, the presentation, if you have any questions, please put them in the chat. So that way I can try to answer them. And just any questions, comments, concerns, mostly questions, because that way, if anyone has a question, if you're not sure, ask it. There's no such thing. There's no such thing as bad questions, only bad answers is what I've been taught. Is it possible for a 6-wheel mechanism drivetrain, and is there a benefit for it? So if I'm thinking right off the top of my head, I was actually thinking about this earlier today when Kickoff released. It would, hypothetically, I think it would be possible to have 2 mechanism wheels on either end, and then a center omni wheel. And that omni wheel would have to be either powered by some sort of maybe a differential, or a like the motor that that you have powering one of the wheels. So just like connect that wheel to the motor as well. What I have seen work is 8-wheel drive mechanism. That's a complex design and it's a lot of mechanism wheels. And there's not really that much of a application for it, but it does. I mean, it could provide better terrain crossing. That's what I can think of off the top of my head. But I don't see a crazy gain for a 6-wheel mechanism drive. If you need 6-wheel drive, I'd recommend going with just a plain regular 6-wheel drive because of the extra traction that you have with it. So yeah, but that's a really good question. That's actually that's something that'll be really interesting to actually try to design and figure out. So, does anybody else have any questions? If not, this is the end of the breakout session, so you can leave. If you don't have any questions, I'll just stick in here till 3 o'clock just in case. So yeah, just once again, any questions, put it in the chat or turn on your mic and you can ask me the question. I should be able to answer it to some extent. Like I said, there's only no such thing as a bad question, only a bad answer. So that's what I've learned.